Yep.
Oh snap. Okay. I had a feeling I was supposed to did it that way, but I did it wrong. I did it the other way, but I understand now.
Okay. That's good. All right, let's go in order. So Ganya, you're first, room 1 for
Sure.
7A.
Yeah, sure. Okay, for the f of x, we have 2x minus 3, g of x, we have 1 minus x squared, right?
It's
Then,
mhm.
yeah, 1 minus x squared, thank you. Then my a is f plus g, the whole thing for 3, right? Of 3.
Yep.
And then I did f3 plus g of 3.
Mhm.
And then I upload 3 on the f of x and 3 on the g of x.
Mhm.
And then it's going to be to give me just 1 sec to read it slowly. I have 2 times 4 minus 3, everything between the parentheses plus open parentheses 1 minus 3
Okay.
squared. Then my results for the f of 3, it's minus 8 minus 3, which is 5, right?
Mhm.
Plus open parentheses 1 minus 9 for the g of x, which is minus 8. Then I have 5 plus open parentheses minus 8. It's going to be 5 minus 8. Then is minus 3.
The only thing is you said that you put in a 4 instead of a 3. So you had 2 times 4, but it was 2
Oh
times
my God, yes, it's
Yeah.
my bad. Sorry.
But your process is good. I just substituted a 3 instead of a 4 for you.
Sorry, thank you.
So,
Yeah.
so you could have done it this way, which was
Mhm.
how Ganya was doing it right here. So you could have done it this way. Did anyone do it another way? Did anyone do it a little differently? Nobody? Everyone did it exactly this way? Every single person?
Sorry, teacher,
Yeah.
in this case, my results, it's going to be minus 5.
Negative
It's
5.
Negative 5. Yeah, sorry, it's my.
Yeah, you're good.
Thank
So
you.
we have to like put them in parentheses because I did it like without the parentheses, but I think I did it wrong because for some reason I got 23.
Oh, yeah, try to look at which step you have a different number or like how you plugged it in that gave you a different number.
Okay.
So every single person did it this way?
No, I seen what I did wrong. I just didn't plug the 3 into my X. So
Mhm.
that's why I had X,
Yeah. So the other way that you could have done this, that I might have considered doing this because we have A, B, C, D here, is you could have plugged in the 3 to the f of x. And then from there you would have 3. And then you could have also plugged in the 3 to the g of x. And from there you'd have negative 8. And then you can go do all the operations. So now that I know f of 3 is 3 and I know g of 3 is negative 8, I could just add them for A, subtract them for B, multiply them for C, and divide them for D, right? Oh wait, no, they're not all 3. Dang, I thought they were all 3. Never mind. If they were all 3, then we
Yeah,
could have
it's
done
true.
that.
It's the easiest way. Yes, I
Yeah,
agree.
yeah.
I agree.
I was thinking ahead to the next problem, but that's another way you could have done it. You could have solved each one and then you could have added them, right? So you could have done that as well, 3 minus 8, and you still would have got negative 5. So both ways work. It's the same thing. It's just if you wanted to solve them separately and then plugged it in, you could have. Yeah, I totally was thinking to the next problem. Okay, any questions on that one before we go to B? It's a lot of people with cameras off. We have a very small class today, so I hope y'all are here and participating.
Mine is on, right?
Yeah, yours is on.
Thank you.
All right, next person, Jade for B.
For B?
Mhm.
Okay, so I had actually just finished A, and I think I like generally understand what's going on, but I don't have it done yet.
Okay, why don't you just try working it with me then?
Okay, so for the first little, the f of x, we're gonna plug in, or it's gonna end up being f minus g, right? It's gonna be
Yep.
f in parentheses f minus g. Is that right? Or
You can write it like this if that's what you're trying to say.
yes,
Right,
that.
right, like that. Okay.
Okay, and then we're gonna set up the rest of the problem, right?
Yep. So we'll substitute instead of f of -1, we're going to actually put the two parentheses -1, all that. So we're basically taking this and we're using that for our f, and we're going to use this for our g, except instead of x's, we're going to put -1.
Okay, so you have the first part set up, and then you put equal to 2, and then in parentheses -1,
Mhm.
3. And then is it boxed or in parentheses, or like is it just to
I use the boxy parentheses just so they don't get confused with the curvy ones, because sometimes when you have a lot of curvy parentheses, it gets a little confusing. But you can use curvy parentheses if you want.
and then in the next part 1 minus -1 squared.
Okay.
And then we're gonna like work the math, right? So like the first half of the problem, it would be 2 times -1, which is -2 minus 3. So that would end up 5.
-5, yep.
And then the second part is -1 times, that would end up being positive, right?
Oh, when you square the -1, that part will be positive. That minus is still out there though.
Okay. So 1 minus 1 in those parentheses are going to be 0. And then you just, I guess, tag on that negative sign. So it's -0.
Uh-huh.
And then it would be f parentheses -1 minus g parentheses -1 equals -5.
Mhm. Isn't that the same as our last problem?
Yes.
-5 on the last one. That's why my brain was jumping ahead. It's funny. Okay, cool. Sounds good. Thanks for going through it. All right. Vanessa, you ready to do the next one?
I wasn't sure how to do that one.
Which piece? Like, are you not sure how to plug in the number? Or
Yeah, I wasn't sure how to plug in the numbers for this one.
do you see how Jade plugged in the -1 for this problem? Like, here's her -1 and here's her -1.
Would it just be plugged in for the f of x and the g of x the same way?
It'll be a 0 instead of a -1, right? Because this problem has f times g of 0.
So would it be f of 0 equals the 2x minus 3?
Yeah, so let's set it up. So f of 0 times g of 0, and then we'll do what you just said. We're going to plug in the 2 times 0 minus 3, and now we got to do g. So plug in 0 for g.
So it'd be 1 minus 0 squared.
Mm-hmm. And keep going.
Would it be -1 for the left side?
So you did 2 times 0, and what'd you get? You're doing parentheses.
0.
Yeah, so 0 minus 3. So what's 0 minus 3?
It'd be -3.
And then on the right side, we have 1 minus 0, because 0 squared is just 0.
Be 1.
Uh-huh.
And then it would be -3.
That's it.
Got it.
Cool. Thanks for doing that one. Anyone have any questions on that one before we go to the last problem on 7? No? All right, cool. Next person. So we have Jerry next. Group 2.
Hello? Okay. So for D, first I did them individually.
Okay, we can do them individually like the other strategy that I had earlier. So I'm
Is it-
assuming you plugged in 2, right?
Yeah.
Okay. So what'd you get for the top one?
So 2 times 2 is 4. So that's 4 minus 3
Okay.
gives
Is
you 1.
good.
And then the 2 square, it's going to give you 4. So it's going to turn into 1 minus 4 equals -3.
Okay. So
Then we're
now
going to do,
I'm gonna write my actual problem now. There we go. And then we can substitute.
1 over -3.
Mhm. So it's like -3rd. Yeah, cool. Any questions on that one?
With the it doesn't matter if the negative is on a 1 or the 3, because I had got 1 over -3.
Yeah, the whole fraction is negative. So it's the same thing, like this is the same as this is the same as this technically in math.
okay. I'm just double checking.
Mhm. All right, any other questions? No? Okay, so now we're gonna go do the next problems, and for the next ones, we do not have numbers. So you're gonna do the same process, but you're gonna be combining your x's, combining like terms, right? Solving it out, combining like terms. Same process, just you don't have numbers, you have x's instead. Okay, so we're gonna do number 13 in groups, so you can practice all 4 operations, and then we'll come back. So I'll type it in the chat. We're doing number 13. There we go. Brian, Fidel, Vanessa, 4 people.
Oh, Brian stepped away for a bit, he said.
Oh, okay. Jade, Vanessa, Fidel.
I just got the last 2 left. I was kind of confused for a sec, but now I kind of understand it.
Okay. Jade, Vanessa.
I said same as him. Like
Oh.
I have the last 2 left.
Okay. And Vanessa?
Yeah, the last 2.
Okay. All right. So let's see, we had Jerry last time, so Brian, but he's not here, so I'll have to come back to him. Carson. Carson for 13A.
Okay, so for these, I'm not sure if I'm doing them right, but I guess you'll be able to tell me or not.
Yeah, let's just try it out.
So it would be 3x plus 1 minus x. And then you would separate those by parentheses, or at least that's what I did.
Yeah, so I'd probably just write above here like this. It's probably what I would write.
Yeah.
And then if you wanted to, you could put the brackets or the parentheses around. You probably don't need brackets now because we're not substituting a number. So you could probably just do parentheses.
Okay.
Yeah. All right.
And then added that together, I got 1 minus 2x, and then I set that to 0.
1 minus 2x. Wait, we have 3x minus x. So is
Yes.
that
Oh, plus, oh my gosh.
plus 2x?
Sorry.
Okay.
Yeah, so plus 2x equals 0, and then you carry the 1 over.
So why did you set it equal to 0?
I thought we had to solve it for x.
No, we're just simplifying it as much as we can.
Oh, okay, okay.
Yeah. Yeah, there's no equal to anything. Like up here, if it said equal to 0, then we would set it equal to 0 at the end, but it doesn't say that.
Okay.
There's no equal sign, yeah. So we're good. And then what would the domain be? Did everyone remember to answer domain? It says in the question, identify the domain. So remember, for domain, we want to see if there's anything x cannot be. And the only things we've talked about where x cannot be something is if we have a fraction and then the denominator cannot equal 0, or if we have a square root and then this has to be greater than or equal to 0. So do we have either a fraction or a square root in this problem?
No.
No, so the domain is anything. I can plug in any x. There's no restriction on this one. So how do we write anything for domain? What will we write? Domain is what represents?
Minus infinity plus infinity.
Negative infinity to infinity. Yeah, that's anything, right? X can be anything.
Excuse me, teacher, here our f of x is 3x only or has something?
It's 3x only, and then there's a comma.
Okay, thank you.
Yep, no problem. All right, any questions on that one?
Yes, I have a question. I thought I was supposed to distribute that positive.
You can distribute the plus, but it's not going to change anything, right? +1 is still going to be +1, and a plus times negative x is still going to be minus x. So we could drop the parentheses and distribute the plus right here, and it would be the same like that. Oops, plus, sorry, like that.
Okay.
Mhm. All right. Any other questions on A? No? Okay. All right. What about B? Let's see who's next. We just had Brian. Oh no, Brian didn't go yet. Brian's still gone. Okay. Fidel, you're next for B.
Okay. So for this one, I did 3x minus, then I put the 1 minus x in parentheses.
Okay.
So then the negative turns to a positive. So it'd be 3x minus 1 plus x.
Mhm.
So then you just combine like terms. So it'd be 4x minus 1.
All right. Awesome. And what would the domain be?
I could do the same domain, right? Since it doesn't have the.
Yeah, it doesn't have any square roots and we're not dividing
Right.
anything. So
So I could just do the negative infinity to infinity.
hope y'all are taking good notes for the absent people, because I think Professor Severs might have forgot to hit record and he hasn't been here for me to tell him. So take good notes in case you need help.
It's still recording.
Oh, it is? Oh, I don't know why it doesn't show on my side. Okay, well, I'm glad it's recording. Okay, next one. Any questions on that one before we go to the next one? No? All right, Alondra, you're next. Are you there?
Yeah, I'm here. So I just like put both of them in like parentheses.
Okay,
So I put 3x times 1 minus x.
okay.
And I like cross multiplied and I got 3x minus 3x squared.
Okay, I think you mean distribute. I just don't want you to get the vocab mixed up.
Okay.
Yeah,
Yeah.
cross multiplying is when you have like this. Oops, equal sign here. Like that, and you multiply across. That's called cross multiplying.
Oh, okay. No, I meant like the little what is it called? The rainbow, I guess. I don't know what it's called.
Okay. It's just distribution. Yeah, that's the
Okay.
real one.
Yeah.
Yeah. Okay, cool. Sounds good. Thanks for doing that one. Any questions on that one before we go on to letter D?
The answer, teacher, is 3 over x minus 1, right?
We're on letter C, and letter C was 3x minus 3x squared.
Okay, sorry. Because I was looking for the one who divide. Right? Yeah, sorry.
Yeah, we're gonna do that one next.
Yeah, thank you. Sorry.
Okay. All right, next is Fernanda. Fernanda, are you here?
Yeah, I didn't get that one, but I could work through it.
All right, yeah, let's try it out.
Okay.
So I'll set up the notation here so you can get a hint on what to do.
So you would put f as 3x
Uh-huh.
over the 1 minus x.
Mm-hmm. That's it, right? There's nothing else we can do. Yeah. The only thing is we forgot to say the domain on that last one. So Alondra, we forgot it was negative infinity to infinity, but we do need to do the domain on this one. So what's the restriction? Is there anything x cannot be? This cannot equal what? What can the bottom not equal? What can we not divide by?
Would it be a 1?
It will be a 1, yeah. We can't divide by 0. So if you want to know what it can't be, do 1 minus x cannot equal 0, and then solve so you get x cannot equal 1.
Okay.
So let's try to write the domain. It can be everything but 1. So how would we write it?
Would it just basically be what you wrote, kind of like the x equals 1 and the line through it?
We have to write it like notation. Does the number line help you? When I did the number line last time, did that help?
Mm,
You can do the number line if it helps. Because this side's negative infinity, this side's infinity. Here's 1. So it can be anything from negative infinity all the way to 1, and then we have to stop, and then 1 all the way to infinity. So let's try to write that out.
would it be negative infinity to positive
So where do we have to stop?
at the 1?
At the 1. So negative infinity to 1, and then we put a union, and then we keep going. We go 1 to
infinity.
Infinity. There you go. Yeah, that circle there is like a stop. It's like a stop sign.
Okay.
So sometimes the number line helps people. So if it helps you, definitely draw it out. In case anyone missed, I said earlier that for C, we forgot to write domain, but it was negative infinity to infinity. So, okay, cool. Any questions on 13, letter D?
I think I missed it. But what was the answer for C?
C, I think was 3x minus 3x squared. Is that what it was? Everybody? Yeah.
Yeah, 3x minus 3x squared. Yes.
Okay. And then the domain was negative infinity to infinity. There was no square roots, and there was no fractions for us to have any sort of restrictions.
So the x squared doesn't affect the domain?
No, it's just a parabola. It just means that it can still be anything. All right.
Teacher, we need to write the domain each time or just when you ask for the domain?
The directions said specifically to find the domain, so we needed to. Yeah.
Thank you.
All right, cool. Well, we'll keep going. I hope y'all are kind of getting it. It seems like you're doing all right. So number 21. Ooh, what do we see in 21 that we haven't done yet today?
Square root.
Square roots. How's that going to affect my domain when I write the domain? What do we know about square roots with domain?
It's a positive 0 to infinity.
Whatever's inside here must be 0 or greater, right? So whatever's in there has got to be a 0 or bigger. So if it helps you, draw the number line like I did, if it helps you to figure out the domain. So use that as you go through number 23. Was it 23? Yeah, 23 or 21, sorry. As you go through 21 to try to figure out your domain in addition to solving these. Okay. All right, cool. let's go to groups. We're gonna do 21. I know we're going a little bit slow today, but I don't want y'all to just like feel like you have to rush through a whole bunch of them and then get confused, because I want to make sure you're really understanding this for your test on Monday. All right, let's go back to groups. Any other questions on this one? No? Okay. All right, we'll go to the next one. So 21B. So we are at Jade.
Said 21B.
Yes. Uh-huh.
Is there a B for it?
Yeah, we're doing A, B, C, D for all of them.
Oh, wait. Oh, okay. I was confused.
Oh, okay.
So I actually didn't finish this one because I was confused.
Okay. Can you try to do it? We're going to plug
Yeah.
in f of x, and we'll plug in g of x.
Okay, so I'm doing B.
Uh-huh.
Okay. First we set it up the same way we did the other one, right?
Uh-huh. Except there'll be a minus, so.
Well, yeah. So it's 21. So it's, we'd set it up. I don't know what the exact beginning would look like, but after the equal sign, it would be the square root of x minus 1
Okay.
in like box parentheses, right? Or maybe
Sure.
not.
Either one, either same
Okay.
thing.
Okay. And then minus, or like a negative sign, and then would that get distributed to g of x?
Yeah, let's write out g of x first. We can distribute it on the next
Okay.
step. So g of x is square root of x plus 1. So that's what goes in that parenthesis.
Okay. So it looks like all we're gonna end up doing is distributing, and oh, I guess it won't be the exact same. I thought it was gonna be like pretty much just or never mind.
It'll be similar, except the
Yeah.
sign will be different.
Okay, you understood what I was starting to say. But so then we distribute.
Okay, so we have square root of x minus 1, and then we got to change the signs on those two.
Yeah, so it would be, yes. And then combine like terms, I guess?
Yep.
Okay. So how would we combine two square roots of x?
One of them's a positive, and then the other one is subtracting.
Oh, so it would just be, never mind. So that would cancel out.
Uh-huh.
And then, so equals -2?
Yep.
Okay.
And then for our domain,
Oh, yeah.
we still had a square root of x at the beginning, right?
Yes. I'm not exactly sure what to do for that. I didn't get to like the domain part and all that.
So Professor Sievers, when they do domain, they don't do it off their answer, right? They have to do it off the original functions and then the substitution.
Yes. So you have to
Yeah.
look at the restrictions on the original function.
When you first were doing the subtraction. Yeah. Okay.
Mhm.
All right. So we won't just say infinity to infinity because of the -2. We have to go back and we see that we have a square root of x here and a square root of x here also. And whenever we have a square root of x, whatever's inside has to be greater than or equal to 0. So
Okay.
if I'm drawing my number line to help me out with it, here's my 0, here's my -infinity, here's my positive infinity. It has to be greater than or equal to 0. So I'm going to close the circle and I'm going to go to the right.
Okay.
So can you try to write that in the notation, interval notation?
Okay. Is it?
So my person has to start here, right? Because the
Yeah.
left side isn't shaded and then we're going that way.
Okay, so is it 0 is less than or equal to x is less than or equal to infinity?
Oh, we're doing interval notation. So we
Oh,
could do
just-
0 to, where's
Just
it?
0 comma infinity?
Uh-huh. And then we're gonna do a bracket on the 0 because it can equal 0. It's filled in.
But it can't go. Yeah, I know what you mean. Okay.
Yeah, we can never equal infinity. We can never actually plug in infinity.
Okay, so that's the domain.
Yep. That's the same as A. We have the same domain as A.
Okay.
Question.
Uh-huh.
Please. We need to do the domain for the original or for the answer. Because here we find for the first one, I find like what I did before, like 2 square of x. This one it's my domain. I know it's bracket, what just right now you said, like 0 plus infinity. But for the second one, we found -2, right? And then here I started to confused which I need to do my domain. Is it for the original equation function as f of x and g of x, or for the results?
You want to do it from when you first plugged in your f of x and g of x before you simplified anything.
You
So
mean
you
for the
wanna-
original equation?
Yeah, before you simplified. So when you had square root of x minus 1 minus parentheses square root of x plus 1, that's where you want to see if there were any restrictions.
Doesn't matter what it's going to be my results, right?
Exactly. Because if I go back to my original problem and instead of an x, I say, okay, let's plug in -3. Technically, I can't solve it because the square root of -3 minus 1, I'm still going to get undefined, right?
Right.
Yeah.
Okay, thank you. Because I want to just make sure if it's, because sometimes they confuse you for each I need to do my domain. Thank you.
Yeah, no problem. Okay, any other questions on that one? No. All right, okay, let's go to the next one. Is the domain making a little bit more sense now? Is it coming back to you a little bit now that we're talking about it?
It's making a little more sense. Yeah, because at first it was like I didn't understand it, but I kind of understand it when you do like the little number line. Yeah.
Yeah, I like the number line. I think it helps a little bit. I like it. Okay. All right. So next we're at Vanessa for letter C.
I did parenthesis square root of x minus 1.
Well, you did square root of x minus 1. Okay. And then times.
And then times the square root of x plus 1.
Okay.
And then I don't know if that's right. I did -1 square root of x for the answer.
Oh, did you? Well, let's do the distribution and see if you got the same thing that we would get. Let's multiply these two first. So what's the square root of x times the square root of x?
Would those just cancel out?
Yeah, and it just become an x, right? Because it would be square root of x squared. So that just becomes an x. So that'll be x because it'd be square root of x squared. And then let's do the next distribution. So that's square root of x times 1. So what's that?
Would that be 1 square root of x or just x?
I mean, we don't have to write the 1 in front, but we do have square root of x is there. All right, let's now do the -1. So the -1 times square root of x.
Would it be negative square root of x?
And then -1 times the +1.
-1?
What we do next?
Do you cancel the ones that are alike?
Yeah, because you have a positive x or square root of x minus x square root of x. So they, yeah, go away. Cancel, become 0 basically. And that's it. But now we'll have to do our domain. And it helps, if it helps, we can draw the number line if it helps.
Yeah, I was confused on where this one would start on the number line.
Well, we have a square root of x. We've got to go all the way back up to where we started. So this line right here, we have a square root of x. So what does that tell me? What's our restrictions when we have square root of x? Square root.
Does that mean it starts at 0?
The restriction when we have a square root is everything inside the square root must be 0 or bigger. So if I go to my number line down here, I know I can have 0 and I can have anything bigger. So I take what's ever under the square root and I make it greater than or equal to 0.
So would it be 0 and then infinity?
And is it going to be a bracket or a parenthesis on the 0?
A bracket?
Yep. All right, cool. Any questions on that one?
Yes, I have a question. Okay, I understand when we need to find the domain and if we have a square root, I understand that. How, I'm just asking, when would my affinity ever be negative?
Maybe my square root underneath, let's say I have, like, for example, the square root of negative x, then I would set that inside greater than or equal to 0. And when I divide both sides by negative, I flip the sign, then that would be negative infinity. That's an example. Because then it would be this way.
Okay, I was just trying to figure out, because I don't never want to get my signs mixed up, because sometimes that's what I do. I get my signs mixed up. So thank you.
Yep, no problem. Any other questions on this one? No? All right, room 2, Jerry, you're next.
We're on D, right?
Yep.
All right. So I did negative x minus, or sorry, square root of x minus 1 over square root of x plus 1.
Okay.
And then I wasn't sure here, but does the 2 square roots of x cancel out?
Oh no, we can only do more multiplying. So if it was like square root of x times -1 and square root of x times 1, then you could do canceling if there was like a multiplication, but it's adding and subtracting, so we can't.
Okay, so then I'm kind of stuck here. I didn't know what to do after this.
I mean, that's all you can do besides besides rationalize, but we didn't do rationalizing in this class, so that's all we
Should
can
I
do.
just leave it like this?
Yeah, so now let's try to figure out our domain. So
Our
I can
domain.
draw the number line again, if that's helping. Negative infinity, infinity. All right. So tell me about the domain.
Do we start at 0 again?
Yeah, so we'll look under the square root. So both of our square roots are the same, right? So we have x is greater than or equal to 0. That's what's under the square root. So that means we'll start at 0.
So we're gonna, so we'll just read the right side of the 0.
Because
it's the same domain as the other ones.
Yep. Now, the only thing I want to point out is this one does have a fraction. So there is something else we're supposed to check. When we're dividing, what do we have to check? What can x not be when we divide?
0.
0. So this entire denominator cannot equal 0. So really, we should be saying that cannot equal 0 and solving that to see if there's another restriction. So that should be part of our work. So we'd subtract the 1 over, right? Cannot equal -1. But can our square root equal a -1 anyways? Without imaginaries, without complex? No. So this doesn't work anyways. But if this problem had been something different, then that would have given us another restriction. So that's why I want to mention it, because let's say it was like square root of x minus 3, then you would have had another restriction. So that's why I want to mention it. In this case, we don't, but.
But we still need to pick the square root of x. Does it minus -1? We still need to put that under in our answer.
No, you don't have to technically, but if it was something different, you would get it wrong. So I wanted to show you, because you won't always have a problem like exactly like this, right? What if the denominator here, instead of a plus, this was a minus? Then you would have to do that part I just showed you. So I wanted to just show it to you, because not all problems are going to have a plus there. It could have a minus, and then you'd have to do the green part I just showed you. You'd have to keep solving the green part. It's just that this one has a plus, so it doesn't matter. But if it had a minus, then we could have. So let me give you an example. So let's say we had, I don't know, x over the square root of x minus 3. Tell me an x that won't work. What x will give me a 0 on the bottom?
That would be a 3.
What x would give me a 0? If I had square root of x minus 3 on the bottom, tell me the number that would give me 0.
3.
Not 3.
9.
9, right? See, so
Yeah.
that would be a problem. Then I would have to make sure I cross off 9 also on my number line. So that's why I wanted to show you the green part, so you don't just think that that never matters. Because in this case, x cannot equal 9. So we would have to consider that on our number line. We'd have to add a stop there, like a stop sign, like I've been adding on the open circle.
So what would be the new domain for like something like that?
The domain for something like that, we'd add like a stop sign there. So we'd have our 0, it'd be closed, and then we'd have our 9 with an open, right?
And then you shade in the middle.
Yeah, you shade that like that. So it's like you go 0 to 9, and then you have a stop sign, so you have to stop there, and then you go 9 to infinity. So it's like that other one we did where we had the union. So that's why I wanted to show you the green, just so you know, it doesn't always work out where the denominator doesn't matter for the domain. So
when you write the 0 and 9 one, so like domain 0, 9, do you do parentheses 0, comma 9?
Bracket on the 0 still, because it's closed. So 0 to 9, and then stop sign. So I do union, and then 9 to infinity. Like that's how you would write that one, that example I just made up.
Okay, that makes sense.
So that's why I wanted to show you that, in case you run into that kind of problem. Like for number 23, you're going to have that. So you want to make sure, I wanted to make sure you understood that. Okay. Any other questions on 21, letter D?
So what would be the domain for the actual problem?
Oh, we said 0 to infinity again. It's the same as the previous parts. So
I'd gotten
bracket.
confused with the second one.
Yeah,
for the
that's why I
example.
wrote example there, so you would know it's separate. Yeah. So, yeah. So if that example, that might come up in your homework, right? Or it might come up in your online homework, on the test, I don't know. So that's why I wanted to give you an example like that, because it doesn't have to be a plus. This just happened to have a plus between them. But if it's like a minus, then you are going to get some sort of number that you can't have. So, all right. Any other questions on that one? Okay. All right. So we are down to 10 minutes. It goes so fast. So I want to make sure we do some of the composition ones. So you'll have to do 23 on your own. I want to do at least one of the table ones, and I want to do one of these composition ones. So let me do a table one just real quick, because I want to make sure if you had any questions. I guess that's 43. Okay, that's 43. All right. So let's do a 43A right here. So again, I'm going to write f of 0 plus g of 0. So I want to at least do one table one so you can see it. So let's go to our table. What's f of 0?
Is it 4?
Yep, it's 4. And then what's g of 0?
2.
2. Yep. And we got that. That was our f that we got, and that was our g. And then y'all can do, you can do the other ones. I want to make sure we have a couple minutes for the composition. So you're going to do the same process for B, C, and D, except you're going to look for 5, -5, and 5. So those are pretty quick. You just have to know how to read it from the table. All right, so let's do a composition one. So let's do one of these. Let's do 61. So this open circle that we have, this is called a composition. It means of, like when you want to read it in English, it's of, so it'd be F of G. That's how we read it. So I can write that on the side. This is read as F of G of 2. So that's how we read that in English, if you just want to know how it's said. What we do is we're going to plug G into F. So what I'm going to do is I'm going to rewrite it because I don't really like it written in the composition form like that. I like to rewrite it like this. This is how you would rewrite it. The second function goes inside with the number. The reason I like to do it this way is because students usually already know that we do the inside parentheses first. So this kind of helps them know where to start. So we're going to start inside the parentheses. So we're going to start with G of 2. So G of 2. And we're going to find G of 2 first. So G of 2 is 2 squared, which is 4. At least with numbers, this is easier. When you get to 75 and 81, we can't really do that because there's no numbers. But with numbers, I like to write it this way. So I know G of 2 is a 4. So I'm going to substitute, since I know this entire piece that I'm circling in green is a 4, right? I'm going to substitute. So now I will have, why is it not writing? F of 4. Before I go on and keep solving, are there any questions on what I just did?
Excuse me, which number are you doing, Anna?
61A.
Okay, thank you.
Any questions on what I just did before I continue the problem?
So I'm just trying to double check for A, when you got everything inside it, when you got the answer to 4, that's it for A. Then we had to move on to B.
No, we're not done. I just wanted to stop in case there was any questions on how I got the 4 and how I did that. We're not done.
Okay, gotcha.
Any questions on how I got the 4 and what I did so far? All right, so now we're going to plug 4 into F. So we get square root of 4 plus 5. So that's square root of 9, which is 3. So my final answer is 3. Okay. Y'all can do B on your own. I want to make sure I do at least one of 75 or 81 to start because those are tougher than this one, but I wanted to at least show you one. Are there any questions before I go on to 75? No? Okay. I can only see 5 students, so let me know if you have questions. This has become a very small class and people ducked out early too. So let me know if you have questions. There's only like, at this point, it's almost like we're all having coffee. There's only like 5 of us here. So just feel free to ask questions if you have any questions.
I'm just asking, okay, I understand how you did it and how you got it. Is there a way that I could put it in the calculator to just double check my answer or no? I'm just asking.
I mean, you could double check each part.
Okay.
I don't know. I'm sure the calculator does do function composition. I just don't know where the button is. I'd have to look. Maybe you could Google the composition button.
Okay.
I'm sure it's on there somewhere in the math options. All right, so let's go down to 75. So 75, I'm gonna rewrite it again. I'm gonna do A, 75A. Let me scroll down. Oh, scroll down to here. Okay, so 75A. So I like to rewrite it because I feel like it's easier to see. So I like to rewrite it. The second function is G, so that's the one that goes inside. Always the second one goes inside. So just visually looking at this, I see that I have G inside of F. So that's how we're thinking about this. I have G inside of F. So I'm gonna take F. So that's 1 over X plus 1. And wherever my X is, I'm going to put G there because G is in F. So this is going to be a 5X that gets plugged in here. So this is G and it's getting put into F. Just like the notation says, the F is on the outside and the G is inside. So G is going into F. And then we simplify. And in this case, the simplification is kind of boring. Not really much we can do besides remove the parentheses, right? 1 over 5X plus 1. That's all we can do, kind of boring. But that's the process. That's why I like to rewrite it the way I rewrote it with F of G of X.
And it's going to be 5 over X plus 1, right?
1 over 5X plus 1.
Okay, yeah. Because yes, I missed that part.
All right, domain for this problem. Tell me what my restriction is. What can X not be for this problem?
No, it's not -1. We distribute with it's -5.
What can X not be?
0 or greater?
We don't have a square root, so we're not going to do 0 or greater. We have a fraction. So what can we not divide by?
Is it 1/5?
It'll be -1/5, right?
Yeah.
We can't divide by 0. So to solve this, remember, this can't be 0. So 5X plus 1 cannot equal 0. So to solve it, so X cannot be -1/5. So if I draw my number line, I'm going to have a stop sign at -1/5. And then I got to go over that because I can't have -1/5. So it can be anything else except -1/5. Someone want to try to write it?
Excuse me, teacher, here the denominator is 5X plus 5, right?
5X plus 1.
Plus 1. Okay, yeah. In this case, it's -1 over 5.
Minus a -1/5, yeah.
-1. Okay.
Anyone want to take a stab at it? Try to write the domain? We shaded
Yes.
it.
Yes.
Okay, what'd you get? Start on this side with your person. Go that way.
Is it parentheses, negative infinity,
Uh-huh.
comma, -1 over 5,
Yeah.
parentheses, union, and then -1 over 5, comma, infinity?
Yep. Cool. Because we had a stop sign, so we had to stop there. Yep.
Excuse me, teacher, look at here. We did the domain for the results. We didn't did the domain for the...
Oh, that's right. We did the domain for the results. So actually it shouldn't have been -1, right?
It's -1. It's not -5th.
No, because we had to plug in 5. No,
Excuse, look, what we
the 5X.
you told me, just what you told me. You said we need to have the domain for the original function. It's not for the answers.
No, the original substitution. Like remember before when we did it, when we did addition and subtraction and multiplication, division, we wrote them in as an addition first, then we looked at the domain, right?
When you do composition, it gets more complicated.
Yeah, it's different. It's different because we're not adding, subtracting, multiplying, and dividing. Now we're doing composition. So when you do composition, we are looking at this. This is still our plugin, right? This is our original problem. And we're still looking there for our domain, which is the same as what we ended up with. It's the same thing.
I want to make sure you mean if the composition we need to look at our results to find
I mean, even not results, when we substitute. So even the other problems we did earlier, those 4, the add, subtract, multiply, divide, I still looked at the first step when I substituted. That's what I used for my domain. I was still looking at the first step, but yeah, so that's the first step here.
Your first step, it's 1 over 5x plus 1.
Yep.
But it's the answer for our composition.
It is.
F
Because we couldn't simplify anymore, right?
Yeah.
So it's the same, but if I could simplify, then I would have to go back and look and see, because I might have simplified something away. That's why I say you look at your first step, your substitution, in case you simplified something away. Like what if on top I had square root of x minus square root of x and it went away? I would have to consider that. All right, we're at time. So yeah, sorry, we're at time. I hope it was enough to help you kind of get an idea. Definitely keep practicing. Remember, the answers are in the back of the book. You have the answers to all of this